Let us look at the second homologous series, which is the alkenes, okay? So this is the second homologous series that we're going to look at in grade 12. Now, they will end with ENE, all right? That is the ending. So they end with ENE. That's how you see the alkene. They will always end with ENE. But remember that the alkanes, which is the first homologous series that we have looked at in the previous lesson, we have said that the alkanes, they end with ANE, all right? They end with ANE. But how about the alkenes? They will end with ENE. That's how you see them. And then the alkenes have got the double bond in between the carbons. Look at that. This is a double bond here. This is a double bond in between the first carbon atom. This is the first carbon atom, and then this is the second carbon atom. All right, so in between the first carbon atom and the second carbon atom, there is a double bond. That's how you see an alkene. They have a presence of a double bond, and that is the functional group. It gives them that superpower. Double bond is their superpower. But what is the superpower for the alkanes? We know that the superpower for the alkanes, we see them by having the single bond. But what is the superpower for the alkenes? Remember, the alkenes, how do you see them? That this is an alkene. Their power is the double bond. All right, that's how you see your alkenes. We don't have methane in this homologous series. Okay, we don't have methane. We don't have methane. We start counting from eth. So we start counting from ethene. All right, so let us draw the structure of this ethene. That is our ethene there. And please remember that eth means 2, right? So that prefix eth means 2 carbon atoms, and we are just going to draw the 2 carbon atoms there. 1, 2. All right, there will be a presence of a double bond in between these 2 carbon atoms. And remember to put your hydrogen atom. So let us put our hydrogen atoms here. This is my hydrogen atom. Remember, your carbon must be surrounded by 4 bonds. It must be surrounded by 4 bonds. This is the first carbon. This is the second carbon. The first carbon has how many bonds? It has 1, 2, 3, 4. I'm just left with the hydrogens that I must put in. So I just need to put the hydrogens, all right? That's what I'm putting here. Carbon number 1 has how many bonds? 1, 2, 3, 4. Those are the 4 bonds. What about carbon number 2? 1, 2, 3, 4. Also having 4 bonds. So please remember that the ENE gives us an idea that this here is an alkene. The part ENE. It shows us that this here, we are dealing with an alkene. Now let's go to propene, right? We know that prop means 3. Prop means 3, and in will mean that this is an alkene. So ENE will mean that this is an alkene. We know that now. Now let's draw the number of carbons. We know that the number of carbons, there are 3 carbon atoms there, right? So it's 1, 2, 3. There are 3 carbon atoms. Now the double bond is going to be here. So the double bond is in the first carbon. In the first carbon now, how many bonds are there? 1, 2. There are only 2 bonds, right? Now we need to add 2 bonds in order for it to reach a maximum of 4 bonds, right? Remember that. So now we're adding this here. Now there are 4 bonds in the first carbon. Now let's go to the second carbon. The second carbon, you have to be careful. Look at this. 1, 2, 3. How many bonds am I left with? Only 1 bond to reach the maximum. We have to reach the maximum of 4 bonds, right? So you put the hydrogen atom here, right? You have to be very careful because there are 1, 2, 3. There were 3 bonds before. Now we add 1. Now there are 4. Now which means that the second carbon is satisfied with 4 bonds. In the third carbon, we have only 1 bond. 1. There are 2 bonds. This is the third one. So that is our propene. These are our structural formulas. For the ethene, this is our structural formula. Okay, for propene, this is our structural formula. So the molecular formula for ethene is going to be C2 because there are 2 carbon atoms. And how many hydrogen atoms? 1, 2, 3, 4. H4. And that's where our general formula comes in. All right, this is where our general formula comes in. CnH2n. Look at that. In the alkanes, we had a +2, but now we have subtracted that +2. All right, we have removed 2 hydrogen atoms. Remember, the N represents the number of carbons, so it's going to be C2. All right, H, and then 2 times the 2 carbons that we are having. All right, 2 times 2 is going to be 4. So that's how you create that molecular formula there. What's the molecular formula for propene? Look at the Cn. Cn. The N stands for the number of carbons. How many carbons are there? C3, right? So it's going to be C3 and 2 times the number of carbons. 2 times 3. That's going to be 6. So it's H6. Can you see how the formula works? This is how the formula works. Right. Now let's go to butene. And we've said that but means four carbon atoms, and then the in will tell you that this is an alkene. Now but means 4, right? So now it's going to be 4 carbon atoms, 1. So we can look at the butene there. The double bond is in the first carbon, and that is going to be butene. That is going to be butene, and the molecular formula is C4H8. Let's go to pentene. Pentene now, it has a number of 5 carbon atoms, and then the molecular formula there is C5H10. All right, now the cycle can continue up until octene. All right, we're going to end up until octene, and then that will be it for the alkenes. I want you now to look at the pentene. Look at pentene, right? The double bond, it doesn't matter if you put the double bond on the far right or you put the double bond on the far left, all right? Here I've put the double bond on the far right, all right? So when we count, it's going to be 1, 2, 3, 4, 5. This is just to show you that the double bond can be on the far right, or the double bond can be on the far left. Just like with the propene and the butene. The double bond is in the first carbon on the far left, but here on pentene, it's on the far right. That is also okay, okay? You can decide to put it there. So these go from ethene up until octene, all right? Unfortunately, I didn't include the octene here, but I'm sure you have an idea now how to draw the structural formula and also to write the molecular formula for these alkenes, okay? You can continue from 8 up until 10. That's also fine, right? And please remember about the functions. So it is also a little bit important to know about the functions of the alkenes. The alkenes are used to make margarine, all right, in the reaction called hydrogenation. So from the reaction called hydrogenation, we can make margarine. That is the function of the alkene there. It is also important to know that ethene is a chemical compound used in plants to stimulate the ripening of fruits and the opening of flowers, all right? So the bananas, we can make an example of bananas, right? The bananas, firstly, they are green, and then at the end, they will be yellow, all right? In order to stimulate that process from green to yellow, we want to make the bananas yellow, right? They start from green, we want them to be yellow in color. So that is the process of ripening them. We can use ethene to actually stimulate that process. That is what is happening. We can also use ethene to stimulate the opening of flowers. All right. So that's it from me. I will see you in the next lesson now when we are looking at the third family. All right. Family, remember, we said family means the homologous series. We're going to be looking at the third homologous series, which is the alkynes. So thank you for watching and God bless.